right, so today what we're going to do is we're going to look at what's called expected number. And it's a very simple idea. It's just how many, let's see, let me write that in a slightly different way. How many of a given population, it could be people, it could be shoes, it could be whatever, right? Whatever population they give you, they're going to give you a number. Would you expect, given a probability? And it could not be easier. Expected number is simply the number of items, people, whatever, times the probability that's given. Now, most of the time they'll give you a probability. Sometimes you have to do the probability first, but that's no big deal, right? Successes over total number of outcomes. So all you're going to be doing is multiplying those two things together to get your expected number. And again, sometimes you will have to find the probability first, but other times they'll give it, for most of the time they'll give it to you. I guarantee you will see this on the external. Right? And it's usually embedded in another question where you've already had to find the probabilities, etc. Right? So, let's just look at a few of these. Just go to Education Perfect. Got some all lined up for you. So, expected number E, it's always capital E, by the way, is just found E equals N times P. Where it's expected number, the number of trials. They say number of trials, it's number of items. So, it's number of people, the number of shoes, the number of desks, whatever. Okay? So here we go. The probability of a AA battery being faulty is 0.0035. What is the expected number of faulty batteries in a shipment of 10,000? So 10,000 batteries is how many we were looking at, right? So that's our N. We're given the probability. All we need to do is take that 10,000 times our probability and tells us that 35 batteries would be faulty. Now, here is the key to making us to success, though, with this question. The expected number of faulty batteries in the shipment is 35. If you do not answer in a complete sentence, you will not get credit for these. So be careful. Make sure you're answering in a complete sentence. All right? Okay, so here's one where they don't give you the probability, so you have to do the probability first. No big deal. An experiment involves a spinner with 5 equal colored sections. So 5 sections. Red, and then they give you the colors. If 200 trials are completed with the spinner, what is the expected number of times you get a green or a blue? Well, green is only one of the 5, so that's 1/5. Or means add, yeah? And then the probability of blue is 1/5, so you just have to do the probabilities first. You add them together, and they change it to a decimal. We did the trials 200 times, so 200 times that probability means that blue or green will happen. We expect it to happen 80 times. Now, expected, does that mean definitively? No. So when you make your sentence, the spinner is expected to land on blue or green 80 times. Do not write will. Okay? Remember, statistics is not about absolutes. Mm-hmm.
So do you have to write expected in every single completed section?
Yep.
At the end?
Yes. Because you expect, that's what you expect to happen. It's not what will happen. Okay? All right. Let's see. Here we go. Here's just another one where you have to do the probability first. A pond contains 480 fish. 220 of those are goldfish. If you selected 130th for the pond, how many would you expect to be goldfish? Well, first we need a probability. Goldfish is 220 out of the 480 total fish. So that gives us the probability there. And then we're going to select 130. So the problem with this one is people want to go back to the big total of fish. We're selecting only 130 of those. So that's the number that you're looking at. So multiplying those two together gives you a nice decimal. But remember, this is an example of a discrete thing. You cannot have part of a goldfish. So you're going to have to round to the nearest whole number. And you can either round down or up. But traditionally, we round up because we don't want to kill one of the fish, right? So it doesn't really matter which one. But traditionally, for people or living things, you round up if you have a part of somebody you want them to survive, right? So there we go. So I'm going to give you this assessment and this task to work on. It's very short and sweet.